welcome. I won't keep on every class, I won't tell part 1, part 2, etc. You can see the title. Part 1 for types of load, that is concentrate load, already over last time, point load. Now we are going to part 2, part 3, part 4, very, very important. See, part 2 is this one, part 3 is this one, part 4 is this one. But make a note, part 2, part 3 and part 4 all come under distributed load. I will explain one by one. As we go further for SFD, BMD or for structural analysis, when these are repeating, what I told now in this class, repeating, I will not explain more and more. I will tell everybody, go back to that mechanics class. I think class number 62 onwards. I made a note there. Okay, now, very slowly I will explain and see that everything is clear. If you go through each and everything, you will get complete control. Distributed load. You see, something you have to write yourself. I will dictate. See, already I told you, point load is load acting through a point. It is directly defined by magnitude. Line of action, you can see it. And point of application also, you can see it. Now, distributed load. See, first, before coming here, see, first you consider for distributed load important. Main, then later. Distributed load defined by intensity. Intensity means magnitude. But remember, this is not total magnitude. It is magnitude of load per unit length. Per unit length. I'll give a small example for you. Suppose you want to buy something. Make a note. You go and ask the shopkeeper, what is the cost? He will tell lump sum. Maybe something where more items are there. Complete lump sum. He will tell. I will tell Indian rupee, sir, 1000 rupees. Over. It is point load. Directly money. Over. Or suppose you want to buy something where he will tell the rate. Suppose cloth. You want to stitch a pant or shirt, etc. What is the cost? He will tell, sir, it is 200 rupees per meter. See, 200 rupees per meter. It is intensity. It is the money only. See, 1000 rupees is money. 200 rupees also is money. 1000 rupees is total, single shot. 200 rupees is the money for 1 meter length. Suppose you want to buy 3 meters. You have to pay 600 rupees. People will understand. So that is called intensity, magnitude of the load per unit length. Length can be anything. It can be meter, millimeter, kilometer. But usually when you solve problems, meter, main is meter. Some rare cases in design of steel structures in a base plate where you take per millimeter. Okay, now, example, W per unit length, symbol. See, make a note. In my class, point load, I considered capital W. You should write it. See, I considered point load by capital W. Some people call P. This I have write. Capital W, or some people call it as P. I can change over to P. No, I want W only, no problem. Capital W. Now, intensity, I want small w. But it is not small w per unit length. Do not give the wrong answer or meaningless statement that W kilonewton per meter. No, W per unit length. But example, see, I'll give some example for you. See, example, further, examples, further. Now you can tell kilonewton per meter, Newton per millimeter, Newton per meter, etc. That is example for intensity. Okay. Like 200 rupees per meter. Somebody may tell not per meter, he may tell in dollars per feet, anything. Okay. Now, defined by intensity, That is magnitude of load per unit length, and the most important term is loaded length. Say L naught in our class. Why I use L naught, I will tell you little later. When people study from me, you stick to L naught. In my class, it is L naught. It need not be L. So, loaded length. This will be explained in the second round now. See, this loaded length L naught will be explained in the second round with very, very thorough explanation. Okay, time being, leave it. This is for distributed load main part. See, what I wrote here is for distributed load. It can be for UDL or for UVL. Either UVL represented by a triangle or by a trapezium does not matter. Distributed load. Load is spread over some length. You can make a note. A distributed load is one where the load is spread or distributed over some length. That length over which it is distributed we call loaded length. But later our L naught is loaded length considered. I will tell you why considered. There is a difference between actual total loaded length and loaded length considered. This all I will tell. Patiently listen to everything. Okay, now, first, uniformly distributed load, or in future, we cannot waste time writing every time uniformly distributed load. We will tell UDL. You can make a note here. See, some things I told I am not in the class I am writing. Uniform means intensity is uniform or it is constant. So, uniform distributed load is UDL. Uniformly varying load. Of course, varying load means for us only linear variation. See, only linear variation. Parabolic variation or variation based on trigonometric functions all, we are not considering. Linear variation. Now, UVL, short form. There are two types. Uniformly varying load represented by a triangle or represented by a trapezium. Both are UVL. Now, uniformly distributed load represented by a rectangle. Now, one important note you are write. I am dictating. In the notes I will write. When you have to represent a load by a diagram, loaded length is along the member. You can call base. Loaded length is along the member. This I told you last class. And perpendicular member or vertically, suppose member is horizontal, perpendicular member will be the intensity. You write here, intensity is plotted, perpendicular member and length of load along the member. Now, if it is uniformly distributed load, see, member is this way. For example, wherever you see intensity constant. When intensity is constant, ordinate everywhere will become same, represented by a rectangle. Like, see, this way. This is the length, loaded length. See, this ordinate is W, small w per unit length. You can make a note here. This is uniform intensity. There is only one W. Okay, then. But later, you write here, note in the class. Later, for UDL, we won't draw rectangle. It becomes more laborious. So, throughout the world, around more than 90% people, they show this like this. But again, remember, this is actually, see, this length is this length. What I wrote here is this height, W per unit length. This is the very popular representation. This is the basic. See, this is actually basic. This is basic. This is popular or easy to understand. Okay. So, everywhere intensity constant. Come to uniformly varying load. From our subject point of view, we are considering uniformly varying load with linear variation. Two cases, subdivision. One, see this way. Uniformly varying load UVL represented by a triangle. See here. Or uniformly varying load represented by a trapezium. Those who are serious, write here. Here, I will tell don't by heart left and right hand. As per the sketch, zero intensity at the left end, which linearly increases to maximum intensity of W per unit length. Only one W. Here W is constant. Here W is here W is uniform intensity. Here W is maximum intensity. So you can write. You can make a small note here this way. See here this way. Right. Here left side zero intensity, which linearly increases to maximum of W per unit length at the right end of the loaded length. Or here left side maximum W per unit length, which linearly reduces to 0 at right end. Or you can tell here from this side, see, if you define from this side, right side maximum, see, left side 0 linearly increases to maximum right end, or right side maximum linearly decreases to 0 at left end. Left side maximum linearly reduces to 0 at right end, or right end 0 linearly increases to W maximum at left end. Here, both ends 0. This is not center, it can be center. And both ends 0, from both ends as you come inside, linearly increases and reaches a maximum W somewhere in the member or somewhere along loaded length. It can be center or somewhere along the loaded length, maximum intensity. From there, both sides linearly decreases. When you reach at the extreme end, it is 0. Right. Here, trapezium, intensity, let it be. Now you require two intensity. Here all one intensity, only one intensity. Here two intensities. For understanding in the class, left side I will call W1, right side W2. Do not by heart W1 more, W2 more. W1, W2. See here. Intensity, minimum intensity of W1 per unit length at the left end, which linearly increases to maximum of W2 per unit length at the right end. Or maximum of W2 per unit length at right end linearly reduces to minimum of W1 per unit length at left end. I think this you can write yourself only. Maximum W1 at left end linearly reduces to minimum of W2 at right end, or minimum W2 at right end linearly increases to maximum of W1 per unit length at left end. So suppose somebody is asking here, intensity decreases or increases, you should not answer the question. You should ask him, you first tell me how you consider. If you go to left to right, intensity increases. If you come right to left, intensity decreases. Here, if you go from left to right, intensity decreases. If you go to right, if you come from right to left, intensity increases. That is the correct answer. So don't commit that here intensity increases. Why? Somebody may see from that side. Okay, this is main part. Again and again go through this one repeatedly and understand each and everything. Now I will rub the full board and consider the most critical part, that is loaded length. Forgotten. I told, as I stopped just now, I told next I am covering the most important part, that is loaded length considered. But before that, see, full you have to understand. This already told for you earlier. We proved it also. See now. Now loaded diagram will come now. See, loaded length considered double shining here. See, I wrote shining. It will come in the next round. For any distributed load, don't tell for UDL, UVL. Even, see, you can make a note. For any distributed load means UDL or UVL, or even load distribution, parabolic distribution, or parabolic of third degree, some trigonometric function, or even irregular shape also. any type of distributed load, magnitude of total load. Again remember, when you tell total load, your hand has to move like this. If I told repeatedly, you are right. When the moment you write total load, it will be equivalent to a point load. See, hand should move like this. Total load. Some people refer as resultant load. No, I will call total load. Total load is given by area of diagram representing the load. For very, very important, loaded length considered. I will tell you what is that loaded length considered. Some will wonder why he is telling. Wait for some time. Okay. Now, see, or that means if it is UDL, area of the rectangle representing the load. If it is triangle, area of the triangle representing the load. If it is trapezium, area of the trapezium representing the load. This is what we will follow in future. Right means what we will follow in future. But remember, I also told you one more thing. Note, of course, another version is there. Is, I forgot right here, is total load equal to average intensity of load into loaded length considered. This we will not use for triangle or trapezium. UDL I will tell you later. So, but therefore remember this area concept mainly, see this area concept, you can write here, the area, you write here, that word area we consider for UVL. For UVL. UDL, there is nothing to worry because very simple. Nothing. Intensity of load into loaded length. So this is usually for UVL right here. But it is valid for UDL also. Why? Area of the rectangle. But we don't require area of the rectangle. We write like this. That I will explain to you. So make a note. Whenever, so now you make a big note. Whenever you got a uniformly varying load represented either by a triangle, you should write big letters, either by a triangle or by a trapezium. Total load, your hand should move like this. Total load equal to area of load diagram representing the load for the most important term, loaded length considered. Okay, now total load over. Now doubt comes. Total load where acting? See, and continue. Same. Continue. And line of action of that total load, where is that line of action? Will pass through centroid. Some people call center of gravity. Both are same. Centroid of diagram representing the load for loaded length considered. That means you write here, for uniformly varying load, make a note. Whenever you want, see, total load, find area for the loaded length considered. And suppose you want to know where is that load acting, what you do? Locate centroid of that load diagram only for loaded length considered. The total load will pass through centroid of the diagram. Okay, this is the most important. Okay, now I will rub this one and now I will tell you the importance of loaded length considered. Now, what all I dictate without writing on the board, those who are interested should write it. Now, the most important term, that is once again see double color, loaded length considered. In our class, it is L0. Okay, now, first class, make a note. If somebody is interested only in engineering mechanics, maybe he is not civil or mechanical. Some other branch where he has to study mechanics in one subject, then you never bother. For you, loaded length considered is the full length of load given, over. But later, when you go to strength of materials, there you get shear force and bending moment calculation. And also, when you go to structural analysis, almost everywhere, you require SF and BM. See, analysis, you require SF and BM. At that time, the loaded length considered is very important. See, this course, even though this course is engineering mechanics, I take precaution so that it is equally applicable when you go for strength of materials and structures. So later, I will tell in the class, go back to engineering mechanics, class number so and so, study and come back. If anything is not clear, study. Okay. Now, this is note you are right. That is, if somebody is only interested in engineering mechanics, he can leave this one. He can leave. That is not civil or mechanical. He wants to study this as subject. For you, this class is of no use. You write a note. I am studying only engineering mechanics for academic purpose. Therefore, for me, this loaded length considered has not much effect. Therefore, for me, loaded length considered is the entire given loaded length, over. But for others, I know 99% of the people who are going through this class are most probably civil and rarely mechanical. Okay, now see, what I told is you consider UDL. See, you write here, consider UDL. I will do one thing now. I will consider UDL like this. See, correct me now. UDL from A to B. A to B. For a length of L, I will tell L. It is not the span. Okay, I will tell this capital L. Okay, because a small L I use for span later. Capital L. Okay. I will take capital L. L. Intensity L I am not writing. Now, see, right here. Right here. If we consider entire load from A to B, then loaded length considered that is L naught equal to L. That is, see here, A, B, UDL, this is your L naught, that L naught loaded length considered equal to L. So your L naught equal to L. Make a note. Now write here. Okay, now make this note. Now I am writing once again now. See. Now suppose later during SF and BM calculation, if we have to find SF or BM at a point in between A and B, say at C. C is not center, random point C. Say C. Okay, write a sketch here, C. That is, now write, that is this way. A, B, somewhere here C. I'll put red color, C. Okay. Okay, now I will come this side now. I will come this side. See, for example, imagine this length is L1, this length is L2. So that L1 plus L2 equal to L. Okay. Now, if you write continuous there, don't come here, but I will write here. Then, right, we will be knowing later. Right now you are not knowing, but I am knowing. I will tell you later. We will be knowing later that you should write it, for finding SF and BM at any point, we have to consider only one side of that point C. That is either left side, that is either left of C or right of C. But remember, only one side you have to consider. Why means right now you are not knowing, I am knowing, so what I tell you believe me. Then what happens? See here. Then see. Stay sufficient? Okay, sufficient. Okay. Then if this is A, this is B, if this is UDL, point C is here, this is L1, this is L2. Then I will do one thing now. I will remove this one. All I remove. Then there is no place here. See. Actually you are right below, no space, I will write above. You write below. Then you write here. Two options. You may either look left side or look right side. See, or. 1 minute. Camera checking. This is the easy symbol to understand. Show the face. Yes, done. Remember, you should not look both sides. You have to look only one side. Why or later? Then those people who look left side, see, those who consider left side, consider left of C, for them loaded length L0 equal to L1. Your L0 equal to L1. And those who consider right of C, for them loaded length L0 equal to L1. Oh, sorry, L1. L0 equal to L2. But remember, this also is UDL. This also is UDL. But remember, if you consider the entire loading, your loaded length consider is L. But for SF and BM later, if you have to consider only one side. You should not look both sides. You should decide at that time. Either consider left or right. Okay. Those who consider left side, they should consider only this much load. We should write here. They should consider only load from C up to A. Those who consider right side should consider load from C to B. Then those who consider to left of C, their loaded length L0 will become L1. Those who consider right side, their loaded length L0 will become L2. So those who look this side, this L1 will become L0, and those who look that side, your L0 will become L2. Be very careful. Okay, now this is for UDL, but whether you look left or right side, even when you consider part of it also, it is UDL only. Now I will tell for other loading. Now you write. Suppose what all I dictate you write. Suppose there is a uniformly varying load from A to B of length capital L, 0 to W per unit length. Then, if we consider load for entire loaded length, then your L0 will become L. Suppose for some reason, if you have to consider the entire load, then L, you write here, again and again I can't write. L0 means, I told I won't write in future. Now onwards, I told L0 stands for loaded length considered. Then loaded length considered is L. But now I am dictating. For suppose you have to find shearing force or bending moment at an intermediate point, say C, somewhere here, at L1 from here and L2 from here. Then I told just now, when you find shearing force or bending moment, you have to consider only one side. You have two options. One of the option is consider this side, left side, or other option is, see the face here, consider this side. Then you write here, I am not writing everything, space is not there. You write here, for those who consider left of C, for them, see, now before that, 0 here, W here, let it be W at C intensity. See, this is maximum. W suffix C is the intensity load per unit length. Then those who are considering this side, they will get a uniformly varying load of intensity 0 here and a maximum of WC per unit length. See, this way. And for them, loaded length considered L0 will become L1. Okay. Or those who consider right side, for them, see, if you consider this side, see here, then they will get uniformly varying load represented by a trapezium of intensity here WC per unit length to W per unit length. They will get this diagram. And for them, loaded length, for them, those who look right side, their L0, loaded length considered is L2. Then I will ask a question in the class. Which is better? Sir, left side better. Yes, correct. Why? If you look right side, you have to struggle for trapezium. If you look left side, simple triangle. That all we will see later. Okay, now I'll give a small example for you, for this one. Small example. Okay. Do one thing. It's a wasting time. No point in wasting time this way. You make a note. Okay, I'll give example first. See, consider a member AB, A to B, this way, 0 to, this is 60 kilonewton per meter. This is the load. Loaded length is, say for example, 8 meter. Right now first, I am dictating, in case you consider the entire loading, then your loaded length consider L0 will become equal to 8 meter. You get a triangle from 0 to 60 kN per meter. Okay. But for some reason, not some reason, suppose you want to find shearing force or bending moment at an intermediate point. This is 60 kilonewton per meter. This is A, this is B. Total length is 8 meter. Suppose you want somewhere here. C, at a distance of fraction, I should divide by 8, 4.8 meter here. If that is 4.8, this will be 3.2 meter. 3.2 meter. Then you should know the intensity at C. This you can get from similar triangles. I will calculate and write directly. I won't waste time. That will be 60 by 8 into 4.8. 36 kilonewton per meter. If you calculate, this will come 36 kilonewton per meter. Remember, rounded off, calculated. Then, see here, those people who look left side, for them, they will get a uniformly varying load of 0 to 36 kilonewton per meter, and their loaded length L0 will become 4.8 meter. Load length here. And those who look right side, they will get a uniformly varying load, see, this side, of 36 kilonewton per meter here, which will increase to how much? 60 kilonewton per meter this way, and their loaded length, out of scale, their loaded length L0 equal to 3.2 meter. Make this note. Now, one more small note. In case uniformly varying load is like this, actually not required to waste time, A, B, C. See, this is WC. This is W. Length L, I will take this as L1 and L2. Make a note. If you consider the entire loaded length, point C will not come. Full triangle 0 to W base L over. But if you want shear force or bending moment, see, if you look left side, now left side you get a trapezium WC to W, and your L0 will be L1, loaded length considered. If you look right side, you get a triangle of loaded length L2, WC to 0. I will ask a student, which side better? Sir, this time this side is better. Yes. Now, same way, last example. So that everything should be clear. There should be absolutely no doubt. Lastly, consider uniformly varying load. Uniformly varying load. This is W1 per unit length increases to W2 per unit length. It is this way. Okay. This is A, this is B, this is L0. Now you write. I am dictating. Suppose you want the entire loaded length. In the notes I will write each and everything. Entire loaded length there, then this is L, not L0, L. If you take entire loaded length, your L0 will become L. Make a note, then write. But, right here, then one more sketch. But, suppose I want shear force bending moment somewhere here, C. Say, then this intensity WC per unit length is required. Say, now, let it be L1, let it be L2. Now, those people who look left side, they will have uniformly varying load represented by a trapezium of W1 per unit length, I put only U, to WC per unit length this way, and for them, their loaded length L0 equal to their loaded length. For them, their loaded length L0 equal to L1. And those who look right side, they will get, here see, trapezium. They also will get a trapezium of intensity WC per unit length here. See, they will get like this. This is WC per unit length. This is W2 per unit length. And for them, their loaded length considered L0 equal to L2. L2 over. Now, I will conclude it with a numerical example. See, I took this way. Now I will take this way. Numerical. I will take reverse way. Very fast will be over. Not much. Just to understand, imagine there is a uniformly varying load, higher here, lesser here. That does not matter. This way. This is 20 kilonewton per meter. This is, say, 36 kilonewton per meter. Loaded length is 10 meter. 10 meter. A, B. This is the loading. Make a note. Those people who consider entire, you should write, if you are serious, you have to write it. Those people who want those people, or when you have to consider the entire loaded length, then undoubtedly 10 meter itself will become L naught. You will get 36 to 20 uniformly varying load. Write this note separately, then write. But in case you want a point C, 10 meter, see anywhere, say 4 meter from here and 6 meter from here. Now 10 meter is not required. Then first you have to find this intensity. WC equal to, I will calculate, this you have to do by linear interpolation, that I will tell you later. 29.6 kilonewton per meter. See, this is 29.6 kilonewton per meter. Calculated value not given. Or if I do from this side, 29.6 kilonewton per meter. Okay. Don't worry now. This all will come later. Then, see, those who look this side, if you have to consider somewhere at C, only one side you have to see, people who look this side, they will have uniformly varying load of 36 kilonewton per meter, reducing to how much? 29.6 kilonewton per meter. This way load, this load they have to consider, and for them, loaded length L naught equal to 4 meter. 4 meter. And those people who prefer to look right side, for they will get 29.6 here, reduces to 20 kilonewton per meter. 29.6 kilonewton per meter here, 20, and for them, their loaded length considered L naught equal to 6 meter. Therefore, remember, last I will tell without looking at the board. In case of UDL, whether you consider entire length or partial length, you get UDL only. One's full length, one's cut length. In case of uniformly varying load of this type, when you consider full load, full triangle. When you consider intermediate point, those who look this side, triangle. Those who look that side, trapezium. But if the load is this way, when you cut here, those who look this side, triangle. Those who look that side, trapezium. Or if it is trapezium this way, trapezium. Whichever side you consider, you get trapezium. First time, full load means full trapezium. Next, when you do partially, then either trapezium to left side or trapezium to right side. These all concepts, remember, required for SFBM. When I give example for UDL, UVL, everything, these all I will incorporate. This number of class will increase. Yes, this is the permanent for up to end of education. What all I am telling now, class number 62 onwards, up to maybe 70, 71, I don't know. It is for the complete structural engineering education. People who are lazy and do not go through correctly and get confused later, they have to blame themselves. See that you are not one among them.